Hi, I'm Stefan. I'm a lecturer and researcher at the University of Applied Sciences, Northwestern Switzerland, here in Muttenz. So as a lecturer, I give lectures in mass spectrometry, spectroscopy, chromatography, but also in lab automation and digitalization. As a researcher, together with the group of analytical chemistry, I'm leading the micro lab. Micro because we do microsampling, so diagnostics of small volume of blood. We do microbiome, so what's happening inside our gut area, and microplastic, and here connected also some PFAS research. In short, this is called here Professor for Instrumental Analytics. And working together with students and a very open-minded and enthusiastic group is really a gift here. I mean, weighing is part of our everyday life. We're analytical scientists, and we take the things precisely. Yeah? And if we lose too much precision on the weighing itself, this will propagate to the rest of our processes. It will be more and more. So therefore, I think it's very crucial for us. As discussed previously, precision is key to do the weighing process, and sometimes we work together with a lot of students. So here in this lab, sometimes we have like 12 to 15 students, and somebody is doing the weighing, and other people are walking just by, and then we need to find ways how to make these things more robust. Also finding the right balance for the right task. So sometimes efficiency matters, sometimes really precision matters. Etc. This is another key thing. So the first application we take a look at today is PFAS. The PFAS topic here at the university started with our colleague Marco Ruprecht joining the university last year. He brought a very special material with him. So this is basically a material that was used for ski wax in the early 2000s. Maybe you remember 20 years ago, the Swiss skiers, they suddenly won over the Austrians, and everybody was thinking about what's the reason behind this. And it was actually a special wax. One of the reasons was a special wax, which really reduced the friction and made them much faster. But afterwards we found out that it's maybe not a good idea to put these toxic compounds that we didn't know at this time on the skis. And the patent was basically lost. But now we took this very same material, and what we did is we coated the anion exchange membrane with this material. And now the PFAS compound, so it's fluorinated chains with an acid head group, sulfonic acid or carboxylic acid. And with this anion exchange, we have this dipole-dipole interaction that these compounds bound on the material. And with the functionalization of the ski wax, we have additionally the fluoride-fluoride interaction, which really makes this material super sticky for these PFAS compounds. And what we do here in the analytical chemistry is we basically fill it in these micro cartridge systems. So here, this acts as a solid phase extraction system, SPE, with the actual material being this type of compound I just described. So now this allows us to really take a large volume of water. So large for us, it's 10 to 100 milliliter, and we filter it over this SPE cartridge. Now the PFAS compounds from the samples, they are trapped in the material, and everything else goes through. And what we do in the second step is we take an elution buffer to then elute the PFAS very concentrated in a small amount here, and then do the analytics. So this is basically the workflow. Now, filling these little things with this material is quite tricky. First of all, the material is some sort it's not a nice powder, it's not well distributed, and we need to fill at the moment hundreds of these cartridges, which is very tedious. So imagine taking a spatula and just filling it all day. The precision will not be very high. So what we basically did is we did some 3D printing that we can put these cartridges on this holder, and now we're using the automatic balance bridge to dose exactly 20 milligram of this material inside these cartridges. And the balance does it with a very high precision, and it's quite robust for our process, so we're happy for this. But the main reason why we're super happy is the dosing head here. It does a little bit of grinding of the material that we fill in here. And what comes out is a super fine powder. And the finer the powder inside here, the better we are able to press this SP cartridge layer, and the more reproducible are our lab processes afterwards. So it's really a combined effect of automation to increase the precision, but also the robustness through the process of this weighing. For our microplastic research, we need to weigh in very small amounts in very small tubes. And the tubes, they look like this, to convince you that they're very small. And here we weigh in 1 milligram on our microbalance over here. We work together with very smart people who really take the time to understand our problems and processes. I really appreciate that. Especially Julien and Andrea, they're even guest lecturers in one of our bachelor modules. So we have this module called Automation and Digitalization. And they come and speak about data integrity and about their processes. And every year they update their lecture because there's so much running at METTLER, and I'm always excited to sit in the audience as well for this part. And yeah, overall, I think it's rather a close partnership, yeah, where we exchange ideas, know-how, and learn from each other. So we see and want to improve more and more digitalization and lab automation in our processes, because analytical chemistry, it's sometimes very tedious in sample preparation, and you have many steps of human error. So building robust processes where you have a streamlined process from A to Z with the weighing, with the interface to other instruments, and maybe even end up with the autonomous lab, this would be our goal. And working on these intersections between the balance and another system, basically, or how to get the data from one platform to the other, this is really key, and this drives us to do more innovation in this field. So METTLER TOLEDO is really a partner for us, where we collaborate and exchange know-how to really make progress and innovation in the modern lab.